Dear friends, welcome to my YouTube channel. I am Dr. Musaddiq Gohir. In today's video, we will talk about Pauli matrices, their eigenvalues, and some of their basic operations on qubits. Pauli matrices are very important tool in quantum mechanics and especially in quantum information theory to perform different operations. And the student of quantum mechanics or quantum information need necessary to be well familiar with the Pauli matrices. Let's suppose here we have a polymatrix X whose matrix is given here, and these polymatrices includes the information about the spin of the qubits and the characteristic equation. First of all, we will evaluate the eigenvalues of polymatrices. For sigma x, here is the characteristic equation determinant m minus lambda I. M is any general name which is given to the polymatrix. The here sigma x and lambda is the eigenvalues, set of eigenvalues, and I is the identity matrix which has the same dimensions as that of polymatrix. So when we put the value of sigma x in that characteristic equation, then by a simple uh, determinant solving method, we will be able to evaluate the values of lambda, which are plus minus 1. So the sigma x has eigenvalues plus minus 1. Similarly, in this way you can calculate the eigenvalues of sigma y, which are plus minus iota, and sigma z, which are plus minus 1. Now here you can see that the very simple method is used to determine the eigenvalues of Pauli matrices. Now let's move on to the next slide. Now we will see the smaller operations of Pauli matrices. So first of all, as you can see that sigma x is applied on qubits 0, so it will give you 1, which means that sigma x or Pauli matrix x is a bit flip matrix, bit flip Pauli matrix, because it has converted 0 into 1. Similarly, when you apply sigma x on 1, it will give you 0. Okay, in the same way, when we apply sigma y Pauli matrix on 0, it will give iota 1. And when we apply sigma y on 1, it will give minus iota 0. So this is basically also bit flip, but it is also changing the phase of the qubit. So sigma y Pauli matrix is known as the bit phase flip Pauli matrix. And now let's move towards the third one. Third one is the sigma z Pauli matrix. When you apply it on 0, it will give you 0. It remains the same, but when you apply it on 1, it will give you minus 1. So it is known as the phase flip Pauli matrix. So these are the basic operations of Pauli matrices onto the two-dimensional qubit lying in the two-dimensional Hilbert space. So in this way we can perform different operations of Pauli matrices. Enough for today, and I hope so you like my this short video. I will be back with new videos. Enough for today. Allah Hafiz.